U.S. forces, it's a dangerous world out there. But the American warfighter has someone watching his back, even though he may never have heard the name. Drive past this complex on a street near Washington, D.C., and it looks like any other office building. There's no logo on the outside, no hint to who works here. DARPA, the Defense Advanced Research Projects Agency. It's the R&D arm of the Defense Department. DARPA enables the game-changing military breakthroughs that others dismiss as impossible.
If I have an idea for a new tank, DARPA's not going to be interested in that. They're going to say, go to a company that makes tanks. But if I have an idea for a hover tank or an invisible tank, and I can show a reasonable scientific plan to get to that end goal, DARPA's the one who's going to fund that.
DARPA has granted National Geographic filmmakers unprecedented access to closely guarded labs, remote proving grounds, and underwater test areas.
Do you have a personal camera, ma'am?
I do.
I'm gonna need that as well.
At DARPA headquarters, we surrender our cell phones at the Visitor Control Center.
There's your badge.
Then we are escorted to the only room where interviews can be conducted. Sometimes, our questions hit a brick wall.
You know what, I don't want to go down that road.
Okay, okay.
The security reason?
Don't want to tell you the secret sauce.
Is that right? Is that something you don't want to talk about?
Yeah, can I not talk about that one? Let's not talk about that for now.
From developing ways to spot hidden threats in Iraq, to designing hypersonic jets that can fly more than 5 times the speed of sound, DARPA tackles what they call DARPA-hard problems.
When you're looking at a problem that's really difficult, you just say, that's too hard to do. And if you answer the question like that, then it's a DARPA-hard problem.
The highest risk possible is when you put resources on something and you have no idea whether it's going to happen. Those are DARPA-hard problems.
The problems that are too hard to solve are DARPA-hard, we kill them.
The world faces a new kind of terror that has transformed the nature of combat. America's warfighters have an urgent need for new weapons and defenses to fight a hidden enemy whose attacks are unexpected and deadly.
He took shrapnel on the neck. He did.
Case in point, how to defend our troops against rocket-propelled grenades. In Iraq, RPGs are a leading cause of combat death. They are cheap to make, fast, and lethal. RPGs can be fired from anywhere and race to their targets in seconds. A seemingly unstoppable threat. DARPA's solution, a revolutionary technology called Iron Curtain.
The Iron Curtain was developed to protect lives of people in armored vehicles, line armored vehicles, against threats such as rocket-propelled grenades.
Many RPGs are so powerful they can penetrate a concrete wall or a foot of solid steel. It takes an RPG about 1/10 of a second to travel 15 yards to its target. DARPA's team has to develop something fast and powerful enough to detect, track, and destroy it in a split second, just inches from the vehicle itself. But can it be done? At a remote site on the Utah Salt Flats, scientists prepare to test the Iron Curtain system on an armored Humvee. It's about to be subjected to an attack by simulated RPG fire.
As the RPG is flying in, the first sensor that sees it is the radar. This is the radar antenna, so they can track the RPG as it comes in. The second sensor that sees it is all along here, there's an optical sensor. And as the RPG flies underneath, we're able to select the exact aim point. The countermeasure then has an effect on the exact point that you want it to. Now, since we can't have explosive countermeasures on the test that we're doing out here today, we use instead a system that we call the diode gun. And we set up the lights in sequence so that they travel down at the exact same speed that the countermeasure would be going. So we can see then, with the high-speed camera that's operating at about 30,000 frames per second, we can see precisely where the countermeasure would have hit the RPG.
Today's test will require pinpoint radar detection of the incoming threat and an instant trigger of the countermeasure system. Before the test, the equipment must be calibrated. They aim the air cannon precisely using a laser.
Okay, that's good. A little bit to the right. That looks good.
We have an autonomous system that's GPS guided. The guides system around the track so that we can conduct our experiments completely unmanned.
In 3, 2, 1, go. All right, let's watch the high speed.
Only by examining the data can technicians tell if Iron Curtain worked in the critical time frame required. Footage shot by their high-speed camera indicates that the sensors detected the incoming RPG threat. The countermeasures would have effectively been deployed in time to stop the RPG in about 1/10 of a second. The Utah test of the Iron Curtain system using simulated RPGs is a success. But can Iron Curtain stop deadly live RPG fire?
In the case of Iron Curtain, we have had several occasions where the system didn't work as planned, and the RPG did go high order and destroyed all of our apparatus. And you just pick up the pieces, in this case literally pick up the pieces, and you push on.
In June 2008, the Iron Curtain system is tested again with live fire.
We had a lot of confidence in the system, although I won't say that my heart wasn't up here. We took a shot. We detected with the radar. The optical system went on, told our countermeasure where to shoot. We shot it, held our breath. And sure enough, we deaded the RPG, went over, wiped the RDX, the explosive off the vehicle, and congratulated ourselves. On that particular Humvee, we only had 3/8" armor, which isn't much, and we shot 5 RPGs at it. So you can see impact points of 5 RPGs on that vehicle, and obviously we deaded them all. We still have our vehicle.
What exactly is the countermeasure dropping to disable the RPG? That remains DARPA's secret. And behind the scenes, DARPA found a way to give our warfighters a futuristic helping hand. On patrol in Iraq, America's soldiers can fall prey to sniper fire. To shield themselves, our warfighters must rely on 30 pounds of body armor for protection. With the rest of their gear, they must shoulder as much as 125 pounds. To give them the extra strength they need, DARPA goes to a place where fact meets science fiction. Scientist Steve Jacobson at Raytheon Sarcos, a leading robotics company in Salt Lake City, is working to create a new breed of soldier with superhuman powers. His creation, the exoskeleton, combines a man and a machine to offer extraordinary strength.
If you put 200 pounds of body armor on somebody right now, they're going to walk about 300 feet. And if you put 200 pounds of body armor on somebody wearing an exoskeleton, they can walk all day.
The exoskeleton mirrors the human body. A computer network serves as its nervous system. Hydraulic valves and actuators function as muscles. And its skeleton is made of aluminum. The challenge of putting a person inside a machine is a daunting one.
When you put a machine around a person, there's all sorts of places where it interferes with your motion. It may abrade your skin.
When you first put it on and it's not powered up, it feels very heavy because you're wearing a 200-pound robot, which is a lot of weight.
Ready to power up? Power up.
As soon as they power it up, all that weight goes away. And suddenly you feel like the Hulk.
Rex Jameson wears what is probably the most advanced design currently being tested by a human operator.
The risk is that it's extraordinarily fast and extraordinarily strong, so if it decides to do something, I can't fight it.
The exoskeleton is designed to amplify the operator's movement without blocking it, to read his motion, enhance it, and make him stronger. The superhuman stamina of the exoskeleton makes it a priceless military asset. It will allow a soldier to lift 100 pounds with no more effort than lifting 10.
When I'm lifting heavy things with the exoskeleton, it's surprising. You look at the object and your brain thinks you can't pick that up. You don't feel any stronger than the exoskeleton, but then you reach out and pick it up and there's no effort at all, and it continually surprises me. It feels like I'm lifting a prop.
How much load are you feeling in pulling 200 pounds?
Maybe 10 pounds.
Moving things is one of the large forgotten jobs in the military, and the exoskeleton was designed to help an individual soldier move boxes all day long without getting tired.
A 35-pound ammunition can, a normal man can lift without much problem, but after lifting 20 of them, they're going to get really tired, and it requires no effort on my part, so I could do it forever, basically.
By reducing fatigue, the exoskeleton can enhance the combat performance of the warfighter. And the exoskeleton is more than strong. It's light on its feet.
The fun part for me about operating the exoskeleton are the speed moves, like the punching bag and the soccer ball. It's very quick and very precise, and surprising given how much power it has, how it can follow you so quickly.
The exoskeleton is the best robot in the world right now because there's no other robot in the world that you can climb into, move freely, do work, and not get tired.
One of the joys of the exoskeleton is watching someone's face who sees it for the first time. Because to them, this has been science fiction, but all of a sudden science fiction's real. They see a machine on a person, and they know tomorrow's here.
The Army is adapting the exoskeleton for supply handling, to help our troops bear the burdens of war. But strength and stamina are not enough. A warfighter's survival depends on locating the enemy. A new DARPA breakthrough answers that need. For our troops, survival means spotting an enemy sniper on a rooftop before he spots you.
Where's that fire coming from?
When Iraq started, it was very clear in the urban area that what people really wanted was surveillance, but they didn't want it from 10 miles away. They just wanted to know what was on the next block.
DARPA's solution, the WASP. It's no bigger than a toy, but looks can be deceiving.
The thing I think that makes WASP so unique is it has all the same features that are found in a full-size airplane. It has an altimeter, it has a gyro, it has GPS, it has a magnetometer. All of these things that are found in full-size airplanes are found in a package less than 26 inches and weighs at less than a pound.
Each stage or block of the WASP, produced by the AeroVironment Corporation, was supervised by DARPA Program Manager Leo Christodoulou.
This is the Block 3 production aircraft. This aircraft has multiple capability with modular payloads, such as this one, which is a high-resolution camera. But it could also have a night vision camera, or indeed it could have an extra battery to give it increased endurance. Think of it as airborne binoculars for the infantry. It has the capability to accomplish complex missions with high degree of autonomy. In cases where it loses communication and has no instructions, it will go to a rally point. It will go to a specific location and wait for you there.
The WASP has already proved effective on covert combat missions, where it can be used to help detect snipers or terrorist hideouts.
One of the key design objectives of the WASP was the ability for a single warfighter to quickly, efficiently, and easily assemble it and fly it in very short order.
What I have in the backpack here is a micro air vehicle that a single man can operate. Here's the air vehicle itself. This is a night camera. And this is the camera we use for flying in the day. This is the controller I use to view the video and control the aircraft in whilst in flight. And this is the RF unit which sends up the command to the aircraft and then receives video. I'm here at a test range in California. We're going to send this armored vehicle somewhere out on the range, way out there, and I'm going to find it with this.
The target vehicle doesn't stop until it's far beyond his line of sight, lost in the distance.
Okay, I've done the pre-flight, system checks are good, and we're going to launch the vehicle and go find that guy.
Powered by an electric motor, the WASP Block 3 can travel at a speed of up to 40 miles per hour. It's capable of flying for 45 minutes to a distance as far as 3 miles away from its operator.
So I'm looking down the road here, and we're just seeing where he might have gone. We're looking to the side, left and right. And I'll just keep looking around. I'm in side view camera here, and I'm just looking to see if we can find him. There he is, there's the vehicle. So we were able to find the vehicle.
Even more surprising than how well the WASP flies is the way it lands.
When the WASP lands, it's designed to break apart in order to absorb air energy, very much like a NASCAR is designed to break apart when they crash. That's the way we design our UAVs, such that when they break apart, the energy is absorbed, the piece parts may fall apart, but then you can pick them up and you can put the airplane right back together again and it's ready to fly.
Not only was it DARPA hard technologically, but it was DARPA fast in terms of getting it into the hands of the operators. We needed to turn this aircraft into a robust, tough little bird that could take everything that a warfighter might throw at it.
With the WASP, DARPA helps put the element of surprise on our side. And surprise has always been part of DARPA's DNA since a day that shook the world. DARPA was founded when one of our enemies took us by surprise.
50 years ago, we had Sputnik, launched by the Russians, which greatly surprised this country. We never believed that they were going to get to space first. DARPA's primary mission from the very beginning is to be an agency whose job is to prevent technological surprise to the United States. Over the years, we have found that the best way to prevent technological surprise is to create it. So we have gone out and created surprise in order to prevent it from happening to us.
DARPA gave America the high-tech edge with breakthroughs like the Saturn moon rocket that began as a DARPA program and stealth technology.
The reason you have a GPS receiver, the reason you have cell phones so small, because DARPA created the technology many years ago.
Many other innovations that DARPA helped to pioneer, from the computer mouse to the internet, have transformed our lives.
DARPA has been involved from the very beginning in enabling the technologies. If we could have a sticker, it would say DARPA inside. And that sticker would go to every high technology product there probably is.
DARPA's quest for advanced technology ratcheted up after the deadly attacks of 9/11. Suddenly, we faced a determined and elusive enemy who posed an unnerving new threat.
I had actually worked in the Pentagon at the time, and after 9/11, word came down that it was imperative that we had systems that could get places fast, over long distances.
DARPA envisioned a game changer that could fly over 4,000 miles per hour, twice as fast as the fastest jet.
Many times there's targets of opportunity and you have very little time to deal with those targets. A system that can fly 4,000 miles per hour from the continental United States has the ability to engage those targets in a very brief amount of time.
In less than 2 hours, this extraordinary aircraft could fly 9,000 miles to carry a 12,000-pound payload to the enemy. But is such a revolutionary aircraft even possible? To find out, DARPA chose as one of its partners Lockheed Martin, a company that has developed many secret aircraft, including the U-2 spy plane and the SR-71 Blackbird, first aircraft to fly over 2,000 miles per hour. Their facility, called Skunk Works, is famous for its innovation and also for its secrecy.
The access we're offering here today is really unprecedented. This facility has well over 1 million square feet and just a few windows. The reason for that is we want to prevent physical access from people looking inside the windows, but also to prevent sounds from being transmitted, as sounds could oscillate through the windows and transmit classified or sensitive conversations. Occasionally we have security areas that require supplemental security protection. In this case, we have white noise being piped in to prevent classified or highly sensitive discussions from being overheard by a casual passerby.
Few discussions at Skunk Works cover subjects as sensitive as this one, a bold new aircraft concept design known as the HTV-3X. Pratt & Whitney Rocketdyne has the formidable challenge of developing the scramjet engine.
A scramjet is purely a supersonic combustion ramjet. To put that in perspective, it's almost like trying to keep a match lit in a hurricane, because the speed of the air blowing past it is in fact supersonic.
Instead of being restricted to a launch pad like a missile, the HTV-3X will have the game-changing capability to take off and land from any regular runway, offering strategic flexibility in a national emergency. To take off and land safely on runways calls for a relatively large wing, but to fly at very high speeds demands a much smaller wing.
Can we make the control surfaces larger?
How to create one aircraft to do both poses a double-edged design problem.
We recently returned from the Lockheed Martin low-speed wind tunnel where we tested our low-speed aerodynamics for the HTV-3X.
Low-speed testing for the Falcon program is part of making Falcon an airplane as opposed to a missile. An aircraft must take off and land gracefully, which means it must fly at low speeds to use existing runways. And so therefore, low-speed testing of these high-speed configurations is critical.
Okay, let's get back together in 2 days and let's see what we got, move on from there.
The details of the Falcon project remain a closely guarded secret, and DARPA scientists intend to keep them that way. While DARPA enhances our potential for hypersonic flight, they also set their sights on helping our combat swimmers. These warfighters often swim long distances to shore before entering combat and risk arriving too exhausted to safely complete their mission.
In the animal world, there are some extremely efficient swimmers. And we started looking at those animals to learn how they swim and see if we can transfer the methods that they use over to people.
This is a pretty close copy of a penguin wing, elliptical in profile. It was actually a failure. Didn't work at all in this case. This wing is very similar to what you'd find on the back of a whale on its tail. Very efficient, very hard to manufacture, so we actually designed it out. And finally, this wing has the aspect ratio of the whale's tail wing, but without the bumps on the front. This is our finished wing, our finished product here. Something easy to produce, but performs just as well as the nature-inspired wing there.
The resulting device, called Power Swim, harnesses human muscle for swimming as never before. With swim fins, a combat swimmer burns 400 calories an hour, but with Power Swim, he burns less than 100. DARPA program manager Jay Lowell shows how the PowerSwim device operates.
The way this works is you buckle this into your leg. You have these springs that help maintain the angle of attack of the wing appropriately, and this back stabilizer foil, which gives you something to kind of push against with your lower part of your leg. And you're essentially going to bend your knees and drive this spar away from and towards your body. When you're doing that, the foils are catching the water. It propels the whole device forward.
At the Naval Surface Warfare Center in Maryland, Jay Lowell has set up a speed comparison test. A diver using PowerSwim against a barefoot diver and one with swim fins. The three swimmers move into position for the race. An underwater signal serves as the starting gun.
Like a shot, he's taking them even from the start. Look at that.
The diver with PowerSwim finishes first. The one with swim fins is left behind. And the barefoot one isn't even close.
The reason we feel that the PowerSwim device is a very significant advance, perhaps the most significant propulsion advance since the swim fin, is that we've managed to improve the efficiency of that diver from 10% to 75% efficient.
Anything that we can give the Marine that'll get him to shore 50% faster while reducing his workload 50% is going to ensure that he is completely mission capable when he reaches that shore.
PowerSwim allows combat divers to swim up to twice as fast and 4 or 5 times farther than before without getting tired. It means they can be dropped off at greater distances from shore, so they're less likely to be detected by the enemy. But this creates another problem. Because they're farther out at sea, combat swimmers face a higher risk of getting lost, and it's imperative they know exactly where they are at all times. To solve this new DARPA-hard problem, the agency developed another breakthrough, the Tactical Underwater Navigation System, or TUNS. The TUNS unit combines an advanced compass and depth gauge with a state-of-the-art sonar system, giving the warfighter his exact position at all times.
The thing that's nice about DARPA is there's no limits to what you can try. The sky's the limit, and no idea is a stupid idea. And so all that does is set all these projects up for success in the long run because they listen to everybody.
DARPA innovations enable our combat swimmers to steer a safe course through hostile waters. And in Iraq, DARPA is helping our warfighters to face their deadliest threat. Improvised explosive devices, or IEDs, have killed over 1,700 Americans and wounded many more. They can be buried by the side of the road, hidden in ordinary objects, and triggered by cell phones. IEDs pose an invisible and ever-present danger. The DARPA hard problem: locate these explosive devices without setting foot inside the deadly blast radius. DARPA's solution: the MAV, for Micro Air Vehicle.
When the MAV successful flight test was first publicized, I got a call from a warfighter currently deployed who said, "We need that now."
The MAV was developed to have a unique hover and stare capability.
They really needed something that would allow them to see over the next hill or around the next corner. The ability to go to a target area and persistently stare at that area and give them situational awareness.
Weighing only 4 pounds, the MAV's remarkable motor delivers as much power as a 25-pound lawnmower engine and literally sucks the MAV through the air.
Air is sucked into that duct by this fan. That's creating the aerodynamic lift.
The ducted fan air vehicle configuration provides vertical flight capability. Plus, it has no exposed moving parts for safety around soldiers, Marines, and airmen.
It can actually fly backwards, forwards, anything it needs to do to compensate for the wind and to put its sensor on its target.
The MAV's sensors include a camera that can detect and recognize man-sized targets at more than 800 feet in daylight and more than 400 feet at night. But today, Honeywell program manager Vaughn Fulton and his team will determine whether the MAV can locate a much smaller target, a concealed simulated IED. In a nearby control center, technicians monitor the MAV's data.
It's probably equalized now. You may not see much, but it'll be a good test of the system.
Right. So, John, during this test, we're going to simulate that there's a suspicious device, and we'll fly the IR over, see whether or not the device is hot.
All right, pre-flight complete. We are good. Video record on. Takeoff command is sent. 4, 3, 2, 1.
Using its heat-sensitive infrared camera, the MAV can detect the temperature differential between the ground and an alien object in the dirt.
Let's see if we can get in a little bit closer to the constraint where I can move the vehicle for this test.
They spot their target. The MAV's infrared camera detects what the naked eye cannot.
Definitely something man-made, different temperature than the surrounding area, so certainly something that you would want to go investigate.
Okay, I've got 26% battery, 25% fuel.
All right, John, let's bring it in for landing.
AV has landed.
The MAV brings a game-changing technology to the battlefield, something the enemy has not seen before and a capability they're not ready to combat.
Our troops face another deadly threat, and unlike IEDs, this one's not man-made. With temperatures in Iraq and Afghanistan that can reach 120 degrees Fahrenheit, sometimes the environment itself is the enemy. Thousands of our troops have suffered from heat exhaustion.
DARPA likes to support projects that will be game changers. In other words, give us a real advantage. And if you talk to any soldier who has been deployed in Iraq and Afghanistan, you ask them what is the major limiting factor for their activities over there, they'll say heat.
Heat can limit physical performance and hamper judgment. And unless the body is quickly cooled, heat stroke can lead to brain damage or death. At a Stanford University lab, scientists Dennis Grahn and Craig Heller have developed a remarkable breakthrough.
We have to be able to run experiments under realistic conditions. We're not in Iraq, so we have a hot room, and then we simulate battle conditions by the clothing that is worn.
A biological chemical warfare suit, heavily insulated for protection, offers the worst-case scenario for overheating in battle.
Now what this is going to be a device that will measure your body temperature at the level of your heart, because all blood coming back from all regions of the body comes to the heart. So that's the best integrated temperature of your body. So when you get this all the way up your nose, the end of it is going to be right at the level of your heart. And for good measure, how about a helmet? Okay, so now we're going to go into the hot room. And hot room is at 42 centigrade, that's about 108 Fahrenheit, so a nice cool day in the desert. Okay, Steve, we'll use the treadmill here on the left. Treadmill up to a 13% grade now. Pretty good workout. Well, we have Steve exercising in the heat, and we're going to leave him in there exercising until his core temperature gets up to 39 degrees. That's about 102 Fahrenheit. So would represent a healthy fever.
When his core temperature reaches 102 degrees Fahrenheit, he is even more heavily insulated.
Okay, Steve, we've now simulated full biological chemical warfare gear by insulating your hands, which would normally be covered with gloves, your face and head, which would be covered by gas mask, goggles, helmet, and your feet, which would be covered by boots. How do you feel?
Kind of warm.
Kind of miserable, huh? Okay.
Steve is left to rest in the hot room, but his temperature still hovers at a feverish 102 degrees Fahrenheit.
Okay, Steve, time's up. So let's make you feel a little bit better.
Craig will cool Steve off using a revolutionary device. They call it the glove.
The gloves are activated, so now we can see how much heat we can actually suck out of your hands.
All right, looking forward to it.
The cool water, which is perfusing this metal cylinder, is going to take heat away from your hands. The hot blood is coming into your hand. It's being distributed in this big network of blood vessels just under the palm, and that heat's being transferred to the metal cone. The cool blood is going right back to your heart and being distributed through the core of your body.
Feels good.
Even though he is heavily insulated, as the cool water circulates through the glove, Steve's temperature immediately starts to drop and will soon reach a safe level. The glove that can protect warfighters from heat stroke can also save the lives of those suffering from extreme cold, including combat swimmers, who sometimes spend 8 hours in freezing water to perform a mission.
How are you feeling at this point?
Feeling a little bit cold.
Dennis Grahn is testing whether he can stop research assistant Tim Wolf from shivering. Even in the chill of an ice bath that simulates the extreme cold a combat swimmer must survive.
Let me see your hands here. Yeah, you can feel they've pretty much closed down. Let's take a look at the palm on the infrared here. Your face is cooling off pretty well. Your nose is definitely shut down. Okay, you reach over and feel your ears compared to the rest of the skin temperature, and they're very much colder. Your core temperature is starting to fall down now, and you can see it's a pretty decent decline, so I think that it's about time to start putting some heat in and see what happens.
I'm not going to complain.
Will that work for you? The way we're going to do it is stick your hand into this little device here that creates a slight negative pressure. What that does is it draws blood into your hand. And so you've got your arterial blood flow out through here, being warmed up in these heat exchangers, and then going right back to your body core where it's circulating around, and the heart delivers it to the core organs. Okay, and you look on the infrared, you can see little spots on your arms are starting to warm up, like right there in your elbow region. Superficial veins are starting to light up as the warm blood returning to the heart is warming the tissues as it passes through.
It only took about 30 seconds or a minute before I started to feel a lot more comfortable. I feel a little cold still, but I'm not shivering, which is a good thing. I think that if this was a real situation and I was really stuck in cold water like this, that these things would be a real lifesaver.
As dangerous as the physical stress of extreme environments is the mental stress of combat. There too, DARPA readies the warfighter to step into harm's way. To help our troops prevail in the second-by-second ordeal of combat, DARPA experts have developed a remarkable innovation in mission rehearsal.
You're being transported out to the area. On the way there, you open up your laptop, and now you see a full 3D recreation of the area you're going to be in. You've never been there before, but it's been built up from you from actually accurate data, so that when you land on the ground, it feels like you've already been there before.
The real-world 3D simulation combines the latest satellite data, ground photographs, and drone footage for a depiction of the combat site so accurate the warfighter can rehearse his mission as never before.
Just the ability to be able to travel the terrain in a mission set in a virtual environment is invaluable. Walking terrain you've never seen before has its own hazards, but if I could have just the rehearsal of walking the terrain, that's tremendous.
The real-world 3D simulation gives the warfighter an extra edge to avoid deadly surprises in combat. Another critical operation for troops is intelligence gathering through surveillance missions, but flying over enemy territory is extremely dangerous. A recent DARPA breakthrough, the A-160, can conduct surveillance at high altitude over long distances without placing a human life at risk.
The A-160 does not have a pilot in the traditional sense. The people in the ground control station, including myself, have control over the bird through a data link. where we give it airspeed, heading, velocity commands.
The pilotless A-160 can hover at 20,000 feet and has set a world record for a helicopter of its size, flying 18.7 hours without refueling.
A-160 is clearly a game changer. Its ability to take off and land vertically and its very, very long endurance and its high altitude operation gathers together a set of capabilities that no other aircraft has ever had before.
Today, at a secure landing field in Victorville, California, the A-160 will be tested carrying a payload that is itself a breakthrough, a radar system called Forester.
The Forester's most impressive capability is the ability to see through a number of layers of tree foliage. Single, double canopy, we'll go through that like a hot knife through butter. So any place where people can hide in foliage, we can find it.
Today's flight test will assess whether the A-160 can safely rotate the massive Forester antenna. Can the A-160 deploy the antenna for radar detection at various angles without endangering its stability in flight? The aircraft is towed into position. The technicians await the takeoff command. Shadowed by a chase helicopter, the A-160, carrying the Forester antenna, climbs to its programmed altitude for the test to begin. Altitude, 5,000 feet. Can the pilotless aircraft remain stable as it deploys the radar antenna for the first time, subjecting the aircraft to maximum torque? It's time to find out. The radar antenna is deployed. The test director delivers the official verdict.
The antenna was rotated a full plus minus 180 degrees, and we flew with the antenna out at 90 degrees as well, so a lot of good data was captured. Today's flight completed a lot of the unknown territory and questions we had with the antenna installed on the A-160. We're very, very pleased with the performance.
The flight test determined that the A-160 could safely deploy the Forester antenna at any angle without endangering the aircraft's stability.
The A-160 can be operated in fully autonomous mode, where we give it a mission plan and then it goes through and executes those commands with no input from the operator.
Capable of flying complex missions without a pilot, the A-160 can carry a 1,000-pound payload, weapons, supplies, and more.
It has the potential to go in and perhaps rescue somebody from a situation that you wouldn't be able to get a person out of otherwise. The aircraft could fly it autonomously, perhaps get that person out and bring them back to safety.
No matter how complex the technology, the A-160, like many DARPA innovations, has a simple goal: to save lives. For 50 years, no idea has been dismissed as impossible if it could protect America's warfighters and keep surprise on our side. And the next 50 years, the people who know DARPA's secrets can only hint at the surprises to come.
There are many game changers that we're working on. Some are as dramatic as having aircraft that stay up for 5 years.
What I see happening in the future is that you'll take precision, bring it down to the level of a bullet, where you actually guide a bullet through flight and change course to the target.
Aircraft which reconfigure themselves in flight. They do it automatically, perhaps a little bird-like. They change their wing configuration. They can maneuver in ways that we've not done it in the past.
Many of the things DARPA works on are classified, so we can't tell you what they are. But what I can tell you is many of those developments are going to change our lives.
In the past 50 years, among its many breakthroughs, DARPA helped bring us the internet, GPS, and stealth technology.